Live, let's go. Okay, we're live. Welcome back to the stream where I'm trying to make a game engine. Before we jump, we'll jump right into the coding in a second. Before I do that, I do need to do the thing I always forget, which is to actually share my stream, because, don't switch device. Luckily, you can't see that. Damn, I'm good at this. Yeah, so this time, in comparison to last time, I did check that I have my correct microphone linked up, and it's not using my headset mic, but my actual dedicated mic that I have on my desk. So that should be good. I'll also put this in here, so that's another. There we go. Yeah, that should work. Perfect. Great. Yeah, that's all that done. I can close this now. That now. Great. Okay. YouTube seems to be working properly this time as well, which is great. So if I give you like a small recap of last week's stream. First of all, my microphone was wrong for half of the stream. Secondly, YouTube crashed at some point. I don't know what happened. My internet cut out or something, but everything was gone. And most importantly, the lights in the background were off the whole stream. Damn, I couldn't live without those lights. Of course, I'm kidding. I'm jesting. Okay. So anything I need to say before we head into coding part of this? It is about time. It is about the right time. Only thing I have to ask, which is on my list as always, is how has your day been? Mine has been pretty good. I'm actually getting some progress done on this engine. So let's go check it out, and let's go over what we're gonna do this week. Damn, my voice is a bit like, hold on, let me just I need to get just a big gulp of water in my mouth because my throat is hurting a little bit. Yeah, okay. That should be better. There we go. Okay, switch. Boom, there we go. Okay. Good, we're at the coding side of the stream now. I always fumble through this first part. Anyway, so what did we do last time? Last time I tried to set up our render frame, which is the part of the application that is responsible for keeping track of all the graphics related data for a single frame, and we have it right here. It has a link to a render API. It contains all the render targets, which is pretty good. Currently it's a pointer of arrays. It's bad. That's why there's a to-do. And then we got a render command list and some other stuff over here to keep track of which what the buffer count is and what index we're at, and just some management indexes over here. Not that important. What do we still need to do in our render API before we can move on to rendering a second triangle or rendering in 3D? It's right here. We started working on a render target heap last time, which is kind of a manager for all of our render targets. And then there's a couple other stuff here, and then maybe by the end of the stream we can get into the renderable class, but I think we're gonna get stuck on one of these. And then after that, it's pretty easy. If we have this, we can just add a second triangle very easily. Which is what all of this is about, because if you remember, I don't know if it will compile, but if you remember, right now, we still, since the second week, we still just have a single triangle. And it should open. There we go. That's all we have. We have had this since the second week we did this. I think right now we're at like week 12 or something. So it's starting to, we need to make some progress. I mean, we're doing a lot of progress behind the scenes, but it's not visible at the moment. So, I did say I'm gonna check my render target heap, right? So that's gonna be the first thing we do, is check what still needs to happen here. And I don't think there actually needs to happen anything. I think by the end of the stream we fixed it. There might have been like one, yeah, there's one to do. Find better way. Because we do like get on a resource, then we cast it, and then we get the raw resource. I mean, not great. But what we could do as well is just, let me just see if we can just do ls, what am I saying, lshp, is it DirectX 12 unique pointer? of a DirectX 12 resource, of this resource. There we go. Like so. Let's just store that resource. DirectX 12 resource. Right. And then we don't need to do this. This is just a unique pointer. Oh, it's a unique pointer to a resource? Wait, what? I'm confused. So this is a resource. This resource is just empty. We do have a DirectX 12 resource, which is in here. DirectX 12 resource. And since it's a struct, we can do this. We don't need that actually. Let's just make a get resource function. That will be way easier. And then we can just return this. Yeah, that makes more sense. Copy this, paste it here, pointer, get raw buffer resource. Source, boop, like that, and it's just gonna be return what? Turn resource to get. There we go. It should be get raw. There we go. And then in here, we do put it to DirectX 12 resource, and we can just do static cast that. Like so. It's just gonna be a normal unique pointer. I pressed 7 for some reason. HP unique pointer, DirectX 12 resource, static cast to this. Boom, there we go. Okay. And then we don't need this. And that. And we can just do this. Boop. We're just gonna cast it to DirectX 12 resource. No unique pointer actually. Man, I need to get back into things. This is getting hard. And then we just do .get. That should work. And then we have the DirectX 12 resource, and then we can just do get raw resource. Like so. Done. Bosh. Great. And that should still compile and give us everything we need. And then I think this is done. So we could have done this last week, but I don't know why we didn't. Yeah, that still works. We still need to figure out, so yeah, this still works. We still got a triangle. I just need to check that we don't have, we do have something over here. Uh-oh. We have a live factory. Uh-oh. That's a bit annoying. So somewhere we are leaking resources. Okay, let's try and figure out why. Let's see. And a live command queue, and a live resource, and a live fence, and a live command allocator. Oh boy. Live lots of things. Let's start with the render API. Did we add something in here? So we added our target heap. This has resources. This has a unique pointer to, so this will get released. This is a pointer to the device, which is fine, because the render API will release that eventually. That's this one. Huh. Okay, I'm not particularly sure what is causing this. Interestingly enough. Factory adapter. Damn. So much live things. That's very interesting. It's not what I was expecting at all. Oh boy, we need to do some proper debugging. Can we get... Okay, let's just go to our application and let's step through what it does, right? So we do that, we handle events, which is nothing, and then we render. But before we do that, we create the render frame. So let's start by not doing that. And then we have render here. Let's just do that. Let's see if it's in our render frame. So we're not creating a render frame at the moment. So we're not drawing anything. We're closing it. Still a live object. Okay, interesting. What if we don't do anything with the render API? So we're not even initializing it. Shader, we're also not gonna do. Run, that's also... No, that's actually okay, we're just not gonna render. That might have been a better way of doing it. There we go. So now, window is still... We should still create a window. We do. Okay, let's see if it compiles. It does. Debug it! Okay, so we still got nothing over here. Do we already have leaked objects? No. Close this. Okay, no leaked objects. Good. Okay, this is what we want. So let's see. If we start by initializing the render API, we probably will have leaks. Okay. Yeah. So there's something leaking in the render API. So we go into the initialize. Let's see. This one. What's our initialize doing? It's probably... Okay, so what is it doing? Creating window, get width, get height, that's fine. Creating a unique pointer to our factory. Oh, it's probably... It's gonna be fine. Okay, so let's... Something in here is failing, so let's start with the factory. Adapter. So let's copy all of this out. Build. We run it, close it. No leaks, nothing here. Okay, next part. We are gonna create a device. This is riveting content, I know. While we're doing this, I don't know if it's considered being scammed, but like I've been trying to set up a third monitor, which is my drawing tablet, so I can like draw and illustrate things. But I mean, okay, so no memory leaks. And for that, I got an extra dongle. I can get it so I can like have another UID HDMI port. So I got this thing, so I can get another HDMI port. But it doesn't work. I mean, it has some USB adapters as well, so I can have more USBs, but the HDMI port doesn't work. And either I got scammed and that thing is just broken, or it's my PC's, because my laptop, I'm doing all of this on a laptop, by the way. So it could be that my laptop's USB-C port, which is what it connects to, doesn't support HDMI. Either way, I'm screwed. Okay, still no memory leaks. Swap chain. Let's create the swap chain. And this is where I think it will happen. Because we create a normal swap chain, right? Now we do this. We do a query interface. Instead of, before we did like an reinterpret cost or something. I mean, we can probably find it back, but I'm pretty sure it's this that's gonna break it. because now we do a query interface, and I think it's because it's ref counted. So yeah, so we have all of this. So I think after this we should actually do new swap chain.release. I'm not sure if that will help. But that's my suspicion. So now I close it again. Okay, and now it's gone. Yeah, so this is needed. So I don't want to do this though. So we're also gonna just make that a unique pointer. Let's just yoink this for a second. Because before I was casting the same pointer, right? But now I'm actually recasting it. So I don't need to do this now. And that should be the same. Ah, I pressed the wrong button. Is it still building? Okay, and if we do this and this. Yeah, okay. So we can uncomment all of this. Yeah, okay, so that was the memory leak. Should have checked this last week. That's that done, and then back in application, we can just uncomment all of this again. Oops. Actually, only this part and this part. Is there anything else? Nope. Okay. So if we run it now, we should yet again have a triangle on the screen and no memory leaks when we close it. Let's see. I'm still missing something. Whoops. What did I forget? Oh, the render. Whoops. Which is quite important if you want to try and render something to the screen. Yeah, there we go. Okay, so we got our triangle. We closed it. Ah, there's still memory leaks. Uh-oh. Uh-oh. Huh. Interesting. Okay. So what if we don't wrap it in a unique pointer? Now if we still do new swap chain dot release, and then we're doing it automatically. I mean, this is what I suppose should be calling, right? Okay. Ah, there's still, so it's not this. There's another memory leak. Interesting. So yeah, let's might be the render target heap. Let's comment this out again. Build and run. Again, back to the riveting, very riveting programming. Oh yeah, no, that makes sense. I should not render anymore. Application. Where's the render? Yep. Let's disable that. Yeah. Boop. Where am I creating a render target? Create render target? Where am I creating my render frame? Oh, whoops. I should disable this one. These are all fine. I don't think these are an issue. Ah, that might actually be an issue. Oh yeah, because I can't do the pipeline stain. Okay, never mind. You're gone. You're gone. You're gone as well. Ah, damn it. Okay, so I got an empty thing. Nothing here. Okay, good. So this is our status quo. Then somewhere here we are commenting stuff. Where is it? Initialize. Oh, it's way lower down. We can create a render target heap now, and this will probably fail. Well, this will work, but this will probably leak something. And that's what we're gonna try and find. Okay, so no leaks yet. Makes sense. No, it does make sense. Okay, and then this will probably also leak without this, just not leak anything. So it's probably our render frame that's gonna be leaking something or other. Yeah, okay, fine. perfectly fine. So go back to application. Let's create a render frame. What this is going to do is it's going to create it's going to create some render targets. I think this is probably there's something going wrong here, I think. Does this keep a unique pointer to the resource? Yeah, it does. Okay, so I think something is going wrong here. Yes, okay, so we got it. Okay. So we posted this, we create a new render target array. We delete the render targets. Oh. No, that's fine, they're unique pointers, right? Yeah, they're unique pointers. So they should all get destroyed. So what is leaking? Okay, let's see here. If I don't do this list, will it work? This is why we need the vector class. Okay. What is it complaining about? Something swaption is probably not used. Okay. Close it. No leaks. Okay, so get swaption is not gonna cause the leak. I'm going this. Here we are creating a raw resource with a 0 pointer. I think at least. Yeah, it's just a no pointer. And we fill it in, which is fine. But the issue might be that we... Wait, but we... Okay. Let's do this. See if that gives issues. It shouldn't. So then it is in our create render target that we get issues, which makes sense. Okay. So we got the line where it's giving issues. So inside here, we still keep moving things just fine. Now we create a render target view. I'm not sure, this is gonna give issues. And that gives us a handle and a render target, and this stores a resource. There's something going wrong with this resource, I think. But what exactly? Who knows? So actually, let's go to a render frame. We should get in here. And I don't know how good the debugger will be, but let's check it. So we got a this pointer, we have a render targets, which should be an array of 2 things, but we'll not be able to see it, will we? No, but we got a pointer to resource, and this resource is a pointer, and then we can't see anything else. Great. Oh boy. But this should clear it. And can we see that by... it's a default constructor. Oh boy. Do we need to release the handles or something? I don't think so. This is also wrong now. We can do this easier. No, get resource. There we go. I don't get it. I seriously don't get it. What is going on here? And the resource is just either empty struct, or in this case it's a DirectX 12 resource which has a unique pointer to a resource, and we should release this, right? I don't get this. I don't. Yeah, so many warnings, so many errors. Oh boy. Something is leaking. I don't know what. It is gonna be something in here, isn't it? This is a heap. That's all fine, right? Yeah. The render frame. The only thing is this is like a unique pointer point, right? But that has a new and delete keyword here and then a delete there. And it's not pointers in there, it's unique pointers, so they should be removed. Okay, let's see. Oh, oops. Let's see, because this has a destructor, so we can technically, if we go to this one, we could say, could get in here, right? And we can do debug break. There we go. We can put a debug breakpoint. I don't know if this works actually, but let's see. Boop. There we go. So this means a breakpoint. This is not what I was supposed to be doing today. Okay, so we got into that one. Continue. We got into first one. Got into the second one. That's it. Yet there's still things that are not... Ah! So that works. So what am I releasing? Oops, equals default. Let's put it back. Okay, so that means that we're... I mean, there's something going on with this resource probably. Unless I have to release a handle, but I don't think so. No. Confusion. This one is set up correctly, right? Yeah, yeah. I got that, I got that. It's a unique pointer device. I don't need to destroy because it's a pointer. We're passing along unique pointers here, so actually let's see if I implemented this correctly. If we pass pointers, which is probably this, pointer equal pointer. Yeah, there we go. Don't need to destroy anything, we're just gonna move it. Wait. What is this? This is wrong. Wait, hold on. This is weird. If we're gonna create a unique pointer, but if we call release, does release do? No, that's correct. Pointer, then we put it to 0 and then we return it. It's not a destroy, which is this, which is reset. I am so confusion at the moment. There is so many as well. Okay. How can we get this correct? I'm so confused. So we create buffering count, which was 2. We saw that this was correct, so we create a render target here, which is moving the resource, which is fine. Actually, let's do it with pointers, see if that works. We're pausing everything with a unique pointer. Let's just pause plain old pointer for a second here, because I'm pretty sure something is going wrong here. So we got a resource pointer, which we can cast to DirectX 12 resource at this point. And then we can get the raw resource, that's fine. And then also inside here, instead of having a unique pointer, let's also just pass a straight up pointer, because that might be the issue here. There we go, like so. That one is fixed. DirectX 12 resource, render frame. I need to fix you now, don't I? Nope. Yes, here. Create render target. We don't need to create a unique pointer. We just create. We just use a pointer here, like so. That should all work. The address of the address. We don't need to move anything. We just do this. There we go. Then this will complain because it still thinks it's a unique pointer. Nope. No longer unique pointer. Don't care about that. Now we don't need to move anything here either. And then this one. Also not be that, but this. Luckily I have, what's it called? Source control. Damn, it took way too long. So I can actually figure this out. I can if this is incorrect, I can get it back very easily. Right? So that's that, and then we still need to fix this one, so it's also a pointer. There we go. And that should compile. Okay, I forgot something somewhere. Create render target with a resource. Oh, a resource. We're gonna make a DirectX 12 resource. Thank you very much. Let's do that here. What if we do this? Okay, this is just debugging ways, right? So we're gonna do that like so. Get raw resource, we're not gonna do anymore, just gonna do this and that. And then we're gonna just say using HP render resource equals, no, we can't do that. Okay, never mind. But you can do this. What you'll inherit from resource. Public. I'm making myself very hard. Okay. Get raw resource, we can't do anymore, but we can just do resource. There we go. Same here, raw resource. Oh, okay, yeah, so it doesn't really matter because it's just a wrapper. 12 resource. There we go. That will do for now. Copy that in there, paste it in here. Yada yada yada. Is it a pointer? Yes, so we're just gonna pass the address. Oh, that's bad. We can't pass the address. Oh boy. Oh boy. Get control time. Okay, let's see. No, I'm still doing that. I don't know what happened here, but these are all fine. These I shouldn't change. Whoops, whoops, wait. No, hold on. That one should be unique pointer. That's fine, that's fine. That's fine. Oh, and there's some at the bottom here. Yeah, so let's go back to this state. Here as well, reset. Here as well, reset. Here as well, reset. This as well. Same here, we can revert all of these changes. Revert all of these changes. See, and this is why you have source control. And then this one as well. There we go. So just have these two files that are different now. Compile. It should still compile now, because we didn't change anything yet, and we will have a massive memory leak. Boy, why am I... It's been so long for just a simple memory leak. Come on. Okay, so we got the memory leak. We have a memory leak due to somewhere inside this create. Like if we don't have this create, I think we're all fine. Technically I can just do and we shouldn't have any issues because we're not calling it yet. Oh, we don't need the raw resource either then. Okay. So this shouldn't give us any runtime issues either, I'm pretty sure, and this should not give us... it might oh shoot, let's hold on. I clicked the wrong button. You. Oh, there's already some issues here. Was it the descriptor heap? Maybe. So even though we're not creating a render target view, we still have issues. do create a render target heap, but it's in a unique pointer, so that's all fine. So this is not an issue. So render frame time, you are probably an issue. So let's just silently not create that. And if we still have issues, something is going on. Okay, no issues, so we do know it's here. Create a unique pointer with DirectX 12. See, I'm not sure what's going wrong here. So we create this, which creates this, which is just this, but this is not the issue, right? Because if we do this, so we move the resource here, which is a unique pointer, which should be fine. I mean, I'm a bit confused here. At the moment, I don't know why. So let's actually, for this render target, what if instead of having a resource, we just plop this in here. And we make it a pointer. And we also make this a pointer to the same thing. Pointer. And then return will just be the resource. Like so. And we don't even need to cast it. There we go. Right? Very simple. I don't think we break any rules with this one, no. So now let's see what doesn't compile, because it will be stuff. And then we'll try and build it up one by one again. Okay, so you first. We don't have you anymore, we just have you. Whoops, 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 whoops. There we go, and that's of course a pointer. There we go. And we don't need to move anything. It's just a pointer, fill it in. Compile. Like this whole stream is gonna be trying to figure this out. Okay, so we just passed a resource here, which is the raw resource, like so. Yes. And we don't move it anymore. Okay, so I do see where the leak is starting to form now. Because now we will still have leaks. Might be less. No, still the same amount. But now we're here. We are destroying this. So this create render target, I don't think we can... Oh no, this is the heap. We can actually get rid of this and we'll make this have a pointer as well to resource. Next step, right? So we do that. And now we know it's either this or the other one. It's just resource. Cannot cost. Yeah, that makes sense because this is struct resource. But let's just give it this. Right, we don't need to cost anything. And we just plop that in there and in there. Why make it difficult, right? F12, let's just give it a resource. Where is it? You. Pointer, there we go. Something will not compile now anymore. Still compiling. Wait for it. Yeah, okay. This one doesn't compile. Okay. So this is a unique pointer. Let's make it a unique pointer reference, oops, to the resource, and do resource dot get maybe. Oh, this is where we can static cost it. So let's get this one out. Copy that, paste it over here. Make a DirectX 12 resource. I will also need to be a pointer. DirectX 12 resource. And now we need to cast it, which we do like so. Again, static cast. Whoops, can't type anymore. Okay, and then that. And now we do that. Dot resource. Ha! Are you a software engineer? Well, I'm a game developer. So, close enough. And let's create render target with that ID resource. Which is this? No? Oh no, it's still a thingamajig. Let's just do that. Like so. And this as well is just pointers. No, wait, this is what we wanted to avoid, right? Okay. What were we doing? I don't remember this. Was it this one? No, it wasn't this one. Was this one? Okay. So from a resource, we go to DirectX 12 resource, and then this is a unique pointer. So we need to do just get raw on it. Whew. Okay, there we go. That one's solved. Then this one is create render target. So we just make that a resource reference. And then this one as well is just resource reference. See what doesn't compile, because some stuff will not compile. Or removing everything, which shouldn't happen either. Yeah, okay, there we go. This is the one that doesn't compile because we're moving it. We can't move it. We can't create. Do we create unique here? Oh, that's bad. Interesting. Okay. Deciding between game developing and software engineering. I am 46 years old now. Well, it's a, I mean, difficult decision to make, I guess. They're quite different. Although probably you're going to be programming in either one. And there's definitely, I know a lot of people that did game development, that studied game development and still went into software engineering. So it's not like you get locked out by studying for one or the other. And a lot of the skills overlap. It's just basically you got a skill set, you got the basics of how programming works, you know how to make performance code, you know how to look at code, how to write it, how to evaluate it. And then you can just either apply it to game development and you can specialize in that, or either you go into software engineering and you specialize there. I mean, either way, it's more what's your passion, right? If you're very passionate about making games, then definitely pursue that. Okay, so raw resource. Oh, this is bad because I don't want to wrap it in there. Oh god, we'll need to keep track of the resources maybe. Okay, let's just hack something now and create a pointer. No, that's just leaking memory if I create a pointer. So I have this unique pointer of this resource, which is too hard to think about. I just have a pointer to memory here. Right, and then I can create a render target, which under the hood will do that, right? So what if, because I know it's a DirectX 12 API call. What if I just yoink this for a second? I just want to see where the memory leak is. So just do that. We know it's ID3 E12 resource pointer resource, right? We don't need to do this, and then we just create a render target with that resource. That should work. And now we just need to specify this. So if we go to this one, we duplicate it, we don't override it, and then we just do ID3D12 resource pointer, delete. Can I make a avatar game hack? I don't know. I can't hack. Okay. This. Boom. Okay. I run it already, but it's not gonna compile, so I don't know why I pressed that button. Yeah, there we go. Thought I was gonna fail. Whoops. There we go. And then, yeah, we don't do this anymore. God, I hope this is DirectX 12 one. Whew, it is. Okay, so then I can just do the resource. Like so. And then this should compile. It should. Yeah, okay, I see compiling. It's an application now. It should compile. And if we run it, and now there's a memory leak somewhere. I mean, oh, there still is memory leaks. Oh boy, and it's probably still in here. So I probably need to call release on that then. Huh. Interesting. Because create render target, it's not doing anything except creating that one. It creates a unique pointer to a resource. Okay, so that render target, then let's do it this way. Let's make a HB render unique pointer of an ID3 D12 resource. There we go. Boom, boom, boom. Done. Resource dot get raw. There we go. And then in the constructor F12. Oh, that will work. Yeah. So this will take ownership of that resource, which is a bit weird. But if this works, okay. Okay, so that explains a little bit of things. So what I did wrong is I had this resource that nobody was owning. I expected it to be owned, but it wasn't. So the DirectX 12 should own the resource, which is what I did here now. But it should just be a normal resource. And then there should be a normal unique pointer. So now we need that to work. And then we do get resource, or we'll figure this part out later. So now this is safe, but we need to make sure that we convey ownership here. So this should be a reference to a unique pointer as well. Well, basically this should already be this, right? So we should have a reference to unique pointers, so we can, in our constructor, which I can't access apparently, I will need to move this data over. Yeah, let's work backwards. That actually makes more sense. So we do that. Then this resource, which is a DirectX 12 resource, needs to have a unique pointer to that resource. Makes sense. So this will destroy it automatically. I don't need this. Right? So this is DirectX 12 resource, which is fine. Okay. Then we need to figure out who makes this render target, just the render, no, it's the render target heap. Create render target, yeah. So here we are creating a unique pointer. This resource should already be a reference to a resource, so there should be an ls unique pointer. Ls, why am I typing ls? HP unique pointer to an HP resource render resource. There we go, and it should be this one, so we can move it here. Okay. Now this resource, we need to get the raw. Right. And to get the raw, we need to get the DirectX 12 underlying resource, which is what we do. Let me just copy it to be sure, like so. Right, so we get this. This is exactly what we need to do. Oh yeah, we can remove this function now. And that will probably be, let's just break it so we know we still need to fix it. Okay, so where were we? We were in the target heap, this one. Yeah, so this resource. So, okay, so let's actually fix this already. And then in the render API, we have some other examples of this. Let me find another example where we make like a DirectX 12 shader like this. Do it on a pointer. So here we make a DirectX 12 resource. DirectX 12 resource by casting the resource to get raw. So this gives us the pointer because to do the DirectX 12 resource, and then DirectX 12 resource we can just do m resource to get raw. That will give us the raw resource. That should work. Now we copy this. So this is not owning it. This is a pointer. To resource, yeah, okay. This one. This. Source. Okay, like so. Then this is called from render API. So that's this one. That gets called, which just doesn't need to do this. Actually, that makes it a lot easier if we can do that. Let's do that actually. Let's make target heap only accept. No, it doesn't need to do that because it needs to pass ownership. So let's do that, yeah. And then this needs to be a reference again. And that will just move it along. Resource. Like so. Now we just need to fix this up to that one. And now we need to make sure that this is implemented from this one. Like so. Okay, what still fails to compile? There should be something that fails to compile. I think it'll be the render frame again. Oh, I made a syntax error apparently. Yeah. One was enough. Oh yeah, this. Get resource will be static cost. Oh, this is a thing I need to fix. To an DirectX 12 resource pointer dot resource dot get. Okay, compile, and I think now let's already go there. It's gonna be this one that fails. Okay, so here we already have this, but let's actually create an unique pointer. Let's create a unique pointer here already. So let's do HP unique pointer of a HP render of a resource. No, we can't. We need to do the raw resource first. So we're gonna create an ID and a unique pointer, HP unique pointer, HP render DirectX12 unique pointer. This is complicated. Of an ID3 D12 resource, raw resource. Okay, so we got our raw resource, and now we need to make a unique pointer of that, which will be create unique pointer of an DirectX12 resource with the raw resource. By moving the raw resource. And then this we can move into here. Boy, that was complicated. And that's just so we can get rid of a memory leak. It's an hour just to get rid of a memory leak. It still fails. How? What? This makes no sense. This abstraction is absurd. This is insane. What if we just do this raw resource, right? So we know this one needs to be wrapped in a unique pointer, but we can do that in here because we don't need to move this pointer now. And then just where we create the DirectX12 resource, we are just gonna accept this pointer like so. Now we're going to create a unique pointer of it. Yeah, and this will release it. It should work. Yet again, I don't know for sure. What? Insane. I don't get it. We move it. We move it. Resource. We move it. Which will get up in here. That's insane. How does this not work? How's my create unique pointer? Let's see. Create unique pointer. Ooh. Oh. That explains a lot, actually. This should be this. Oh boy, if this works, I'm gonna be mad. It's a good bug to find, but oh god, it should have been not there. Yeah, this is a forwarding reference, otherwise we were just making copies, which is probably what we were doing. Ah, it's still there though. I don't... There's something wrong with this forwarding reference. Right? There has to be. Very, very confused at the moment. Okay, time to look up on the standard library. Forwarding reference. Forward. I know what it does. I have already looked it up once before. But I need to know... I need to know what it does. So let's see. So it's just forward of T3. Clause of... Yeah, this is what I need. ST forward of. Make unique. It's just you, that, forward, that. Okay, so I don't need any here apparently. So that's correct. But I'm not sure why we still have a memory leak then. Okay, so create it here, which this is just a normal resource. Huh. Right, this has to be a pointer, by the way, and this has to be moved, and it's moved again, and then here we cast it to that, and then create a render target view with it, which is fine, right? Just point to a resource. And then we move it here again, which is fine. And here, reference, directs, move it into this, which is a normal unique pointer of resource, which is this one. Uh-oh, I see what's happening. Oh, but this is such a stupid one. Oh, public resource. See, this is actually a lesson in why you need virtual destructors. I don't know why it's complaining, because actually we shouldn't have virtual destructors here, but it's default. But it might cause some issues. But I don't think we actually need one, because it's all on the stack, but just in case. And then destructor equals default. It will say that I need to overload it. Let me actually check how I do it. No, like that is perfectly fine. Oh, and let's do delete copy and delete move as well. Resource, and let's make it a class now. Not that it will limit anything. And then same for you. Make your class final public, please. There we go. That's all fine. Let's see. There might be like a pre-declare that's wrong now. So yep. Where's the other one? Class. Huh? Same one. Same one. And the frame, same one. Render target. Class. Let's see. Oh, okay, there's still more. Yeah. This one. Remember, is inaccessible. No, it's not. It's public. Oh, whoops. Now it's public. Class. Resource. Okay. Let's do a find for this. Let's do a struct resource. That should be class now. It should also be class now. Compiles. No memory leaks. Oh boy. Yep, that will do it. That will definitely do it. At least, hey, at least this is a very important lesson. If you if you override for something, virtual destructor. I knew this. It's just an annoying error. Why did it not complain? I should have warnings for that. Anyway. So do we need to clean up anything now? I think so, right? Because we do get buffer here, then we create a unique pointer. This is so complicated for no reason. I mean, I can just do this in here without issue. It will automatically move it for me. Like so. Okay. Oops, that's a print screen. Wrong button. This one. This one. There's like a... Yeah, so we get this, and then we do get. And then inside here, we should really add a get resource, right? Or inside render target itself even. This one has a get resource, right? Yeah. Since it's a class, it's probably best to do get resource. So we can't get the raw. Yep. That's a good plan. So let's in here make an ID D3 D12 resource get resource can't be const, and then it's gonna return return resource to get raw. And then this is gonna be private now. And then this might complain now. But we have a get resource function. There we go. And then render target heap should do the same thing. It should do get resource here. Nice. Compile. Hello, welcome to the stream. Making a game engine. And at this point, I think I actually can show you what we've got so far, which is, it's not a lot. Oh wait, I still have the render function too. Okay, well, let me just, okay, still no memory leaks, which is good, because that's the thing we're fixing. But let's enable all of this code again, and then we can actually show off what we still have. Okay, and then where's the render? Enable rendering again. Let's hope nothing crashes now. That would be embarrassing. It doesn't seem to be. Okay, great. And then, boom, triangle. Still like to do that. And no memory leaks. Okay, good, done. Where's the scratch pad? So I have this list of all the things we need to do. Done the first thing today, which is finishing the render target heap, which is a concept in DirectX 12 to keep track of all our memory for render targets. Made my own, that works. I think we don't have any to-dos in here now. No, yeah, looks fine. This was sketchy, but we figured it out. We figured out our memory leak. Dang, that's good. Actually, let's, because we know, right? Where's our debug layer? Enable leaks, report live objects. Does this return an H result? It does. What does the H result say? Does it save its memory leaks? Because if that does, then we can throw in assert and I wouldn't have that issue anymore. Return is okay if successful. Okay. Not so useful. Can't we check if it has anything? Because report live objects just says it. But I think, whoops, we can just take a look at what's in there. Where's the functions? Debug. So there is only a return live objects. Which debug layer have I? Do I have one or two? I have one. What do you have? It doesn't show, but it's debug 1. So enable leak tracking for thread, which I think is enabled. Yes. Okay. That's all the functions you have? Oh boy. Oh well, then we'll have to do with that. I was hoping we could... Actually, let's print out the H result here. Let's actually already throw an assert result equals uh-oh. How am I gonna do this? I'm actually not sure. Let's think. We just also always want to do this. So let's see if this works. Let's actually do that. And then when we close, we should always get an assert now, and we will be able to see what the error code is. The error is 0 in this case. Okay. So what if we have a memory leak? How can we simulate a memory leak? Very easily. Oh, I know. What if we just disable this one? You know the memory leak we had before? If it still says 0, then we have an issue. I'm hoping it is not. Ah, it's still 0. Oh, that's unfortunate. Because we did have memory leaks. Yeah. Okay. That was worth a thought. But no. So let's remove our memory leak. And unfortunately, from our debug layer, yeah, this is not gonna help, is it? Unfortunate. Oh well. Next thing on my list, what was it? Let's see. Oh, it's creating a dynamic array. Oh, great. Okay, so basically I noticed that we have this list over here, right? This one, which is a pointer to unique pointers, which if we look in here, it's a static array. We know it beforehand, but we still need to create it. Well, we don't know beforehand, so it's a dynamic array. So I want to make a dynamic array concept. Most well-known one is the one that, well, the standard library had, which is standard library, the standard factor. I want to make my own. Okay, so let's see how. Okay, so first things first, we need to put that in our core library, and core library is here. So open a folder, go to engine, core library. How are we calling it? I think, this is my opinion, is that dynamic array is a way better name for it than vector, because that's exactly what you want. It's a dynamic resizing array. What the hell does vector mean? Nobody actually knows. Okay, so we need this. Yes, whoops, I deleted the file. That's not what I wanted to do. Anyway, can I just Control Z that? Yeah. We are also gonna make a .cpp because I think we'll need it. No, it will all be .inline. We'll need an inline file. And then in our CMake list, of course, we also will need to add it. But I actually... do I want to make source groups? Probably. Because in my core library, I want to be... I just want to include containers, right? For now, no, it's fine. We're just gonna do dynamic array. .h and inline, and then whoops, we're gonna move these two so it makes sense. There we go. Then we'll need to rebuild. Select the project, and this will add it to our solution. So in here we should now have, if it's done building, eventually, if 16 seconds is quite long actually. Might need to look into that. So we got our two new files in here. So pragma1, and then we're gonna create our class dynamic array. And actually, I think we're gonna type name T, so that's gonna be thing, and then we're also gonna put it in a namespace, which is HP for homebrew, which is the name of the engine. Class dynamic array. There we go. Whew. Okay. Now, what does every single array need? Well, first of all, we need to create that. We need to create that. And then we're actually gonna have to implement our copy and move constructors for once. Do I want you to copy a dynamic array by chance? No, I want an explicit copy, right? We're gonna leave copy and move. But we need those. And then we're gonna have insertions. So we're gonna have to do and place. Actual and place an item. And actually we can return that item. And in place is actually one that will use templates again. Type name ..t_args, and it's gonna be an t_args double reference ..arguments. Okay, so what this is gonna do is when we create one, it's gonna emplace one at the end. So it's gonna emplace construct it basically. And then that's all we need for the moment. We will get like a size as well. But let's start with this, right? We have an emplace and that's it. Then private, we're gonna have to store something. What do we store? We store an array of pointers. Data. And also, what do we need? We're gonna need two ints. One int will be the size. And int, well, reserved size. There we go. Will make sense in a bit. Like so. I think we're ready to actually start implementing it. So inside here, we're gonna include dynamic array. Now we're gonna start making it. So dynamic array of t dynamic array. There we go. Gonna start with an m size of I don't know what. And then we're gonna call reallocate with reserved size. Size is 0. Reserved size, we're gonna put at 2, and then that's wrong. Come on. Data is a null pointer. This structure is gonna be very simple. We're gonna be HB dynamic array of t. Well, that's the emplace. That's too early. Dynamic array. It's gonna be if the size is bigger than 0, then we're gonna delete the data. Non-owning. Non-owning. If you do pointers in there, it's not going to destroy them. Okay, so the reallocate, how's that gonna work? Because that's gonna be a very important function. And I think this is actually one of those cases where I will make two private fields. Reallocate with an int size, reserve, new reserved size, like so, and that should be a void. And then we're going to implement that. Allocate, there we go. So what is this going to do? First of all, well, reallocate, yeah, okay. So we're gonna set m reserved size equal to new reserved size, just to be sure. And then we'll need to move over every single one of our data. How are we gonna do that performantly? Well, we need to... Actually, that's a good question. How are we gonna do that performantly? Basically, we need to create our new array, our new data, and then at the end, so at the end, we're just gonna do mdata So basically what we're gonna do is we're gonna do new data. New data equals, which is gonna be again a t pointer. It's gonna be a new t of new reserved size or whatever you want to call it. There we go. And at the end, data equals new data. Okay, all good. But now we need to move all the data we already had to the new array. So we need to do a for in I equals 0, I is smaller than m dot size plus I. Always a plus I, it's faster. And now we need to copy. No, we need to move them over. So we're gonna say new data con I equals to do move m data dot I. And this is slow. We can actually do it better. You know how we can do it way better? Oh, we can just memcopy. So we're actually gonna memcopy instead. We're gonna do a memcopy from, I need to look up what it does again. Standard library, it is memcopy. Oh, it's student memcopy? Apparently that's not implemented, so we'll need to figure out define in C string? Okay, well, I guess we'll include that one. Include C string. Oh, also, how do I actually do this? Do I do the double one? Yes, okay. So actually at the end here, we're gonna do include dynamic array data, and then this should also have a pragma once. Almost forgot about that. Okay. So we do have memcopy. What does memcopy do? Destination, source, and count. So destination is this, source is this, and count, is it in bytes? Yeah, it's in bytes. So we need to do m size times size of t. There we go. And that's it. That's all we need to do. That should work. Let's sort of reallocate. We set a new size, we create a new array, we copy over the data, and then we assign it. Good, right? We don't need to do anything else. Except, no, we need to do mdata.delete. Release a new data. There we go. That's it, I think. You will need to look into memory corruption, and actually we're doing like a lot of new and deletes, right? We might have to look into having a debug layer for this, which might be next actually. I think that's quite important. So actually we should create memory allocation, memory leak detection actually. I think that's quite important. It's not gonna be for today, but I do think we need to do that before we actually move on. And then we still need to create our mplace function, which we'll do after the reallocate here. So if we type mplace, the reference mplace, there we go. Okay. So now we need to be very smart. What do we need to do? First of all, we need to see if we still have space. So if size is bigger than or equal to our m reserved size, meaning we don't have size anymore, we're gonna have to reallocate to reverse size times 2. Oh, oops, times 2. This will make sure that we have enough space. And then we do m data size, you can do size plus plus, I don't like that, equals t, and then we standard forward arguments. There we go. And then we increase the size. Plus m size. Done. That's as simple as it is. And then we return data size -1. That's it. That's our allocation. It's not that hard, is it? Well, it will get more complicated in the future because you can't actually create all of these things. But for now, we're implementing a simple, very, very simple case here. For now, we're gonna delete copy and delete move. But in the future, we'll add them because they're definitely the reason we should have dynamic arrays, is so we can copy and move them around, especially moving them around. And we basically already wrote the move. So yeah, okay, that's that. Next thing, is that everything actually? I think so. That's all we need for now. This will be a class that we have a lot of functionality in, but for now that's fine. And then in render, cancel. I wasn't gonna move a file, what the hell? In our render API, so like I said, we have a render frame, which has, now we'll have an HP dynamic array of these. Put the HP in front. I like the HP in front. Okay. So now we got that. We have a dynamic array of unique pointers. Anything else that will not work here. Okay, so this doesn't need to be this anymore. This will also need to change. We don't need to delete anymore, so we can get rid of our destructor here. Default. Actually, we don't need it to be virtual either. Did I remove it already? Yes, I did. Yeah, okay, no, I forgot something very important, which is how we get our data, right? We need to make our operator here, which for now we're gonna do t pointer and const. Let's start with the const one. Operator, this one, int index const, and this one as well. Like so, for int index, and we're going to implement these as well. So our operator, let's see it. Nope. Dynamic array, the const operator, yeah. So we're gonna assert that our index is smaller than size, index out of bounds, and we can put the index in there. And the bounds are 0 to whatever we put in there. So index is out of bounds. Yeah, there we go. Bounds checking. And then we can just return data index. And same for the non-const version, but non-const. So easy. So if we then go back to render frame, this should work now. This also works. But that's a bit weird, right? Because this is assignment. That's not how you do that now. We are actually going to append. This actually works because we're getting a T reference, which will be, what will it be? It'll just be uninitialized data, I think. But the size will make sure it doesn't do it. We're gonna do and place here with Rambit API. There we go. And this will create what we need. It will forward it perfectly like we want. It will be perfectly fine. And then one thing I do want to do is we get the buffering count here. I actually already want to create in dynamic array a separate constructor which will have an int reserved size. And then copy this. And we're gonna do int reserved size. Oh wait, just wrong one. This one. And reserved size. I also always like to have my default constructor, my default constructor as the first one. Oops, no, not this one. Like so. Now we can reallocate it correctly. There we go. Compile. Let's see if we actually did it. I don't know actually. I hope this works first, right? Oop. Okay, what is this? Oh, it's a uint. We can make a uint on a dynamic array. Yeah. No issue at all. This should be units. 32T. That should actually probably be size T's, but sure. Actually, no, let's keep them ints. And then can we... Oh, it's signed unsigned mismatch. Gap buffer wants a uint. I'm not sure, but there should be like a way to disable it. Because again, here we're gonna have signed inside mismatches. Which makes sense. I do want to use unsigned ints here. So let's do unsigned int. Uint 32. Let's just do uint 32t, and if we get into problems in the future, it'll be fine. I don't remember who includes the uint. Somebody will have to. Probably render frame already includes it. Defines. No. 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 It's unique pointer. Oh, type traits probably includes it. Ah, but that's not what I want. Somebody will include it. Just don't remember which one will. No, no. Window and the target. This one is it. This one. That's the correct one. And the frame. No, which one was it? This one. No, it's dynamic array I need now. There we go. I might still complain about things. Still complaining about things. Great. Following. Okay. More uint 32 conversions needed, I guess. Reallocate. Index, index, u. Int. Compile. There might still be some issues. We'll see. Okay, at least it's compiling a bit further. Oh, it compiled. Great. So if we do this. Okay, still got a triangle. Close it. No memory leaks. Okay, that's actually working. I didn't expect it to work from the first get-go. Okay, great. Oh, we got a dynamic array now. Even though it's a very simple implementation, we can't move it around, which is bad. But I do want to check memory allocations. It's not gonna be for now. I'm gonna like start rounding off and ending. But I do want to do something else because I remembered something. Is that we have these two floats here. We don't need these. We have these. And vector 3 and vector 4. There we go. So we can use those and that should still work. And I don't think we actually need vertex in here either. So we can actually yoink this. Go to this. It will complain here now because it doesn't know vertex, but we can just in a namespace here, which is unnamed, put the vertex. And that just took compile. Great going. Thank you very much. Yeah, game engine, almost done with the rendering side of things, at least the basic side of it. I still need to manage 3D, but I have everything wrapped so that if I want to change to another API, I can actually do it. But yeah, got triangle. Cool, triangle, done. No, yeah, and we got the dynamic array, great. That's a big one, I like that one. Okay. Yeah, that one done. But that's where I'm gonna end it, I think. I was gonna hope we get into here, but we got a little bit stuck with our memory leak issue, which was a basic issue. Oh my god, I'm mad at myself for that one. So yeah, got that. Next time I do want to finish this, but I mean, we'll see. We will see. I'm doing it at my own pace. It's a very slow pace. I still have a big list of things to do. This is just the beginning. I didn't write anything after ECS, but I do know how to do it. And now we got some things over here as well. Oh my god, it's gonna be awful. But next time I do want to look into memory leak detection and then looking into proper synchronization. So that's probably gonna be for next time. And then afterwards, we'll look into all of these things. And once that's done, we can have triangles. And we can add them a little bit nicer. But yeah, I'm happy I figured out the memory leak. Man, we lost basically a whole stream to memory leak detection. Oh my god. Well, just to one single memory leak. Oh, it's horrible. Either way, this is now finished. We got our triangle. I'm gonna end the stream for today. I hope it was okay. I think we did. I mean, we didn't do much progress, but it is the absolute definition of do check your basics. I did hope my compiler would warn me against them, but oh well. So we got our thing here. We got everything done. And that's about it. Yeah, I'm gonna see you next time. So let me find the end stream button. There it is. So yeah, hope you have another rest of your afternoon, evening, I don't know what. Just enjoy the rest of your day, basically. And I'll see you next time. Goodbye. It's done.